In example 1, we're given a rational expression, and all this means is we're taking a polynomial, things that we've been working with up to this point, but now we're dividing them, but leaving them as fractions. So here we have the polynomial 10x cubed minus 15x squared, but it's being divided by 10x squared plus 50x. To simplify it simply means cancel any common factors. So it's not written in factors, but I'm going to try to factor it apart. So let's give it a shot. So for the numerator, we have 10x cubed minus 15x squared, and I'm going to take out the greatest common factor, which is a 5, and also an x squared. And then we can see what's left over. And we're left with a 2x minus 3. So I've factored apart the numerator as best I can. And for the denominator, I can factor out a 10 and also an x. And what is left over is, okay, we have an x plus 5. And I can't factor this any further. So here we go. It's the same rational expression, but now it's just written in a factored form. The reason I'm factoring it is so I can start canceling things that are common. So I see like there's a factor of 5 that can come out from the 5 and the 10. I can cancel, well, it's really, there's an x to the first, but I can cancel x to the first with one of those. And now I have this 2x minus 3 and an x plus 5, and I can't simplify that at all. Those aren't identical or differing by some type of multiple. So if I go across, in the numerator, I'm left with a 1x times a 2x minus 3, and in the denominator, I'm left with a 2 times x plus 5, and this would be an acceptable answer where I factored, I removed every common factor, and all that is left over, you can even distribute it if you'd like to. We have 2x squared minus 3x divided by 2x plus 10. I think those are, both fine ways to express our answer. The top one is factored, the one on the bottom is expanded. One thing to point out, which is wrong, you're not allowed to cancel things separated by plus or minus signs. Like, by that I mean, you can't just say, oh, well, 2's, I can cancel those, and oh, like maybe this x could cancel with one of these. No. You can't do that. You're only allowed to cancel things that are factors. So this that I just wrote here is wrong. But up here, like, this is good. You can leave your answer just like this. There are no factors remaining to cancel, and that's the final answer. So not only are we going to just simplify a rational expression, but you can also add, subtract, multiply, and divide them as well. And in this lesson, we'll focus on multiplication and division. So here we have two pretty complicated rational expressions, 2x squared plus 11x plus 5, divided by 3x squared minus 19x minus 14, and that's being multiplied by this x squared minus 49 over 2x squared minus x minus 1. And you could just directly multiply the numerators and the denominators, and that would take a while. Maybe a better approach would be to factor them. And if there's anything that's common between them in the numerators and denominators, cancel those things. So that's the approach I'm going to take. I'm going to start with the very first fraction, and I'm going to try to factor that apart. I'm going to do the same thing with the denominator. So let's see. For the top, I would need a 2x and an x. I see that everything is positive, so it would be plus and a plus. And now I need two numbers that multiply to 5, yet somehow would add to an 11 in the middle. And like with the previous work we've done, I see how this is going to work. I'm going to place a 5 here because I'll get a 10, and a 1 here, one more would take me up to 11. So if I do a similar approach for the denominator, okay, it'd have to be a 3x and an x. Okay, well here it gets a little tricky because now like there's a positive and a negative that's going to go into play. If I'm going to multiply to 14, I'm going to go with 2 and 7. You could use 1 and 14, but I'm guessing a 2 and a 7 will probably work. Okay, well, 3 times a negative 7 will give me a negative 21. Right, and then a positive 2 more than that would bring me up to a negative 19, and there we go. That factored the denominator. Okay. Now for the second fraction, same idea. I want to factor as best I can. And x squared minus 49, this one's a little bit different. We haven't really come across this, but I'm going to take the same approach where I have an x and an x. It's not written in there, but off to the side, you know, this is really x squared. There are no x's remaining in the middle, but there is a 49, a negative 49 at the very end. I think what's going on here is, for the 49, I'm going to use 7 times 7. One of them will have to be a positive 7, the other will have to be a negative, and those balance to give you 0 for the middle term. So if I do a negative 7 and a positive 7, that should factor x squared minus 49. You can check to see that it works. If you have equal but opposite numbers, you should get a 0x squared for your middle term, which is exactly what I want. And then the last piece is going to be, let's see, a 2x and an x again. Multiplying to a negative 1 is great because it could only be a 1 and a 1. And I just want to make sure I put the negative and the positive in the right spot. If I get a negative 2, yet a positive 1, that would balance to a negative x in the middle. So here we go. It took a little bit of work, but before we multiplied, I factored, and the reason is to see if I can cancel any common factors. So this is the fun part where, hey, look at this. There's an x minus 7 and another x minus 7. They're in different fractions, but everything's being multiplied together. This is just like one giant fraction. So anything in the numerator, any numerator, can cancel with any factor in the denominator. So here I'm canceling factors. Let's see, is there anything else that cancels? So here I have a 2x plus 1, and I have another factor of 2x plus 1, so those completely cancel. And I don't see anything else that is similar. So I'm just going to copy what remains down. I have x plus 5. I have x plus 7 divided by 3x plus 2, and then x minus 1. So I'm just putting those into one fraction. And that's multiplied together. Again, you could multiply out the numerators, so that would be x squared plus 12x plus 35. You could multiply out the denominators, which would be 3x squared. We get a plus 2x and a minus 3x, so that's a negative x and a minus 2. And I mean, either of these is completely acceptable. Both of these answers are fine. This one is multiplied together, this one's just expanded out. But the idea here is, before multiplying, factor, see if there's anything that cancels to make the multiplication a little bit easier. And for the last example, so right, we multiplied, now we're going to divide. All right, well, division of two fractions will be no different than if I was to say something like, you know, what is 1/2 divided by 3/4? And what you do is you change it to multiplication by flipping the second fraction. And before multiplying, again, canceling any common factors, so the answer here is going to be 2/3. But this same idea will work with anything that has a variable in it. I mean, a variable is just something that's a placeholder for some number. So I'm going to rewrite this entire problem. This is really x to the 5th minus 10x to the 4th divided by 9x squared plus 6x plus 1 from switching it to multiplication, provided that I write the second fraction as 6x squared plus 2x divided by x to the 4th minus 10x cubed. And now I can use the same process that I did in the previous example, where I'm going to now factor everything, cancel all common factors, and then I'll have my final answer. So for the very first fraction, the top's kind of nice because all I have to deal with is a greatest common factor. So I'm going to take out an x to the 4th, and I'm left with x minus 10. Oh, all right, well, for the denominator, I'm guessing we'll have two pieces. Actually, this one's kind of nice. I'm I'm going to use a 3x and a 3x. Everything is positive, and the only choice for the last number is a 1 and a 1. And that works, right? You get 9x squared, you get a 1 at the very end, but if you double the 3's, it takes you to a 6. I mean, I really could have written this thing as, you could have done this if you noticed it, this is really 3x plus 1 squared. This is just a special case where if you square something, you're going to double the value that goes here for your middle term. You'll have the square of it to start with and the square of the number at the end, but you could still use the same approach that we've done before by guessing and checking. Anyway, for my other fraction, for the numerator, I can take out a 2 and an x, and I'm left with a 3x, what do you know, 3x plus 1. And then in the denominator, I can take out an x to the 4th, and I'm left with an x minus 10. You know, for a lot of these problems, like if you look up some in a textbook or online or something like that, I mean, they're kind of set up so you might end up with similar factors, so kind of like keep that in mind when you're working through these. Like, there was a 3x plus 1, I kind of anticipated another one showing up somewhere, but at this point, we can now start canceling stuff. I have an x minus 10 and an x minus 10. I'll choose this one, 3x plus 1, and this 3x plus 1. I have actually an x to the 4th and an x to the 4th, and all that is remaining at the very end is going to be a 2x and a 3x plus 1, and that's my final answer. I can't cancel anything else, there's no common factors, and there it is, 2x divided by 3x plus 1.